Hello, my name is Jonathan Hocker, and today we will be talking about the ETL process. For many organizations, the extract, transform, and load system, or referred to as ETL, is a heavy burden that must be conquered in order to build a data warehouse/business intelligence environment. There are various requirements that must be considered when establishing the ETL system. This presentation will present a proposal for an ETL modeling process followed by a draft of a dimensional model. Steps on how to gather business requirements necessary for the ETL system will be discussed, along with how to leverage a modeling tool and data profiling tool that suits Duke Energy best. Topics of data storage, database administration, data virtualization, master data, metadata, and data governance will be introduced throughout the paper, with a conclusion bringing all the concepts together. The ETL process is the process of pulling data from various source systems, transforming applicable data, and then loading it into the data warehouse system of the company. As previously mentioned, there are 3 steps in the process: extract, transformation, and load, and these steps are crucial to have a successful DWBI environment. A step 0 of sorts, gathering business requirements, will be covered as this action is the focus of the entire process. The business requirements are what the DWBI users are needing for information. What the business needs are drive the selection of data to put through the ETL process. An effective way to gather what business requirements are necessary is to hold meetings with various business representatives to discuss what key performance indicators must be represented in the data warehouse. In addition to these brainstorming sessions, document analysis, interviews with other employees, surveys, and hands-on observation can lead to requirements for the ETL process. Throughout the process, having proper database administration will allow the ETL system to work fluidly. By the end of the business requirement gathering process, ideally prior to it, a database administrator should be assigned. The database administrator will be in charge of a myriad of tasks, but some of the most important are planning for the physical requirements for the database, ensuring data is reliable, monitoring the status of the database, and securing the database to authorized users. It is crucial that the database administrator plans for how the data being used in the data warehouse will be stored. Whether it be in the cloud or in-house servers, the chosen method must accommodate all the data types that the source data contain. The most critical element is ensuring the loss of data is virtually non-existent and that storage can scale as more data is brought in. Of course, considering the budget and creating the best solution in a cost-effective way is important. Once business requirements are established, extraction can begin. When deciding what sources to extract from, data profiling is done to describe the content, consistency, and structure of the source. By using a data profiling tool rather than creating one, the process is much more productive. Data profiling will produce expectations on how much data cleaning needs to be done, limitations of the source, and realistic schedules. Data is typically extracted into a staging area where data is checked for relevancy, duplicates, data type, and key placements. The staging area is then used for transformation. Now that the data has been extracted into the staging area, it is time to clean, cleanse, and merge the data together. This is where calculations can be done, filtering is set up to select what should or should not be loaded, and data validation to prevent unwanted data can be set up. Prior to those actions, an emphasis for master data management and metadata will be placed. Master data management, or MDM, is typically a set of data lists that are shared and used across multiple applications within the system. Generally, master data for customers, products, locations, and other are created that will be referred to when queries are ran or when data visualization occurs. In order to create these master data lists, pulling from all source data together and cleaning and standardizing it is necessary. For example, for the customer master data, a customer named William Jones must appear the same for each instance. Having a customer appear as William, Will, Bill, etc. will not provide accurate information, and these master data lists are being created to be the go-to for their respective categories. Fixing these inconsistencies as early as possible is ideal, but the transformation stage is where it must be stopped and corrected. Metadata is essential for both the technical and business side. Metadata is essentially data about data. For business users, the name of a table, a column name, any sort of description that will provide more insight of what the user is looking at will make the process easier for all involved. For technical users, having the source database, what the target database is, and source and target tables, columns, and more can and should be included so documentation can guide the data from beginning to end. A data dictionary should be created that provides an in-depth information on what all the data indicators mean. Now that the data has been extracted and transformed as needed, it is time to finally load it into the target data warehouse. Updating the data warehouse with a new load badge can vary. For Duke Energy, a daily or weekly load should be the minimum so new analysis can be done consistently. It is important that the process be optimized so that frequent loads do not take hours upon hours to complete. During these loads, database administration should be taking place to monitor the loads and modify any issues that arise. Data virtualization is increasingly becoming a standard in the modern-day era of ETL. The use of data virtualization integrates data from the source systems and provides a virtual layer that can span application, formats, and locations. It does not actually move or copy the data, but it provides faster access to data and performs data replication and federation in real time. Data virtualization has become increasingly popular as big data has been rising. One of the biggest benefits of data virtualization is built-in data governance, which is necessary to keep data secure and accessible only to the proper users. Data governance is a crucial element for any business. For example, general sales personnel in the Charlotte division need to only see information based on the Charlotte location, but their supervisor needs to see information for all locations of Duke Energy to compare and analyze with those other locations. Through data governance, users will be set up in a group that enables what they can do, what data they can access, and what ways they can manipulate that data. It is essential that data governance be set up with representatives from all departments to decide upon how many groups and roles will be established. The visual shown is a draft of what the dimensional model for utilities would look like. Once loaded into the data warehouse, the information for date, customer, employee, and energy would be constructed into dimension tables. From there, they would all connect to a utilities fact table by corresponding keys that would also have the capability to perform measures such as sales, cost, and revenue. Duke Energy has both electric and natural gas energy types, so users would be able to query data off the types of energy as well. For Duke Energy, Oracle provides Oracle Enterprise Data Quality for profiling and data modeling with Oracle SQL Developer. The Enterprise Data Quality tool has built-in profiling with the ability to parse and standardize data, along with an automated match and merge that can drastically reduce time spent doing this task manually. There are also verification tools and integration with Oracle's master data management as well. Oracle SQL Developer can be used in traditional and cloud environments with a simplified structure that produces productivity. This data model works well with many business intelligence applications such as Power BI, so connectivity with visualization tools is seamless. The ETL process is necessary for a business to properly establish their data warehouse with secure and reliable data. It is important for database administration to occur along with setting up how the data will be stored. Through data profiling and data modeling tools, master data and metadata management can be streamlined and data governance can be created. As big data expands for Duke Energy, data virtualization is a tool that should be utilized for faster access to data as well as maintain data governance. Thank you.